Okay, Bismillahirrahmanirrahim. Assalamualaikum and a very good afternoon. So welcome to SEEE 2073 Signal and Systems, and this is for section 1. Okay, this is basically the outline of the course for 15 weeks. So please make sure you have flipped through the course information provided in the e-learning, and you can check the syllabus and also the assessment method and assessment schedule as shown in the course information. And also please make sure you read through all the information provided in the announcement part. Make sure you have joined the Telegram group, and also you have you scanned the QR code every time following the lecture schedule. Okay, this is to summarize the assessment method and references used in the course. So you are about to have 4 quizzes altogether, and each quiz contributes 5% each. And you will be having 2 tests, test 1 and test 2, in which each contributes 10% of the total marks. And the first test will take place on 10th of May. It is on Tuesday from 5 to 7 p.m. and it will be an online test. And the second test is proposed to be conducted on 14th of June, again on Tuesday from 5 to 7 p.m. and again using online assessment. And you'll be having a magic group assignment which contribute 10% out of the total marks. You'll be having a peer review and also a report, and this assignment purposely to assess the team working skills. And finally, you will be having a final exam which contribute 50% out of the total marks. And the main references used in this course are the BP-LATI, Linear System and Signals, and also from Rawat, Signals and System, and the publisher is the Oxford University Press. Okay, so today we are going to start with the first chapter entitled Introduction to Signal and System. Okay, this is the synopsis of the course as mentioned earlier in the course information file. So you'll be exposed to basic properties of signal in both time domain and frequency domain. Okay, so topics covered in this course includes basic properties of continuous time and discrete time signal, Fourier series, Fourier transform and Laplace transform. Both Fourier transform and Laplace transform will be in frequency domain, and you'll be using the concept or theories that you have learned in Fourier to design a filter. Okay, so this slide summarizes the importance of studying signal and system. Okay, for example, it is basically fundamental to all engineering, as you'll be exposed to analyzing a signal by knowing its mathematical equation. So different signal will be represented by different equation. So later on, the information can be used to design a system. Okay, why you need to learn this subject? What is or are the motivation? Okay, so for information, this subject is basically a prerequisite to the following courses. The first one is SEEE 3533, communication principle. This is the third year subject, in which you will be applying basic knowledge that you have learned in signal and system in this particular course. Next, in system modeling and analysis course, and also in digital processing signal. Okay, this slide shows the example of a practical system. When you have an input signal that will be transmitted to the end recipient or the receiver. So this is the original image. Then you send it into the system. If there's no process involved or done in the system, the recipient may receive a noisy or disturbed image. However, since we have the system included some filter and some process, so the information sent by the sender can be received at the receiving end as similar as the image sent by the sender. Okay, what is signal? What comes into your mind when you heard signal? Okay, so signal is basically a physical time varying quantities that carry information. So the keyword here is physical quantity, carry information, and it varies with time or space or distance. Okay, for example, we have temperature, human voice, signals, radio signals, stock market, and etc. So then, what is a system? Okay, a system is basically a processor, a signal processor that will extract information from the received signal, and then it will modify the original signal before it is sent. The signal is sent to the receiver. So the input signal will be sent into a system or a processor before the output signal is generated. Okay, these are the basic types of signal that you'll be dealing with in this course. The first one is the unit step function, then ramp function. You'll be seeing rectangular signal, unit impulse as well, sinusoidal, exponential, and sine norm function. Okay, so what is unit step function? So unit step function is given by ut. Okay, the amplitude is 0 when t is less than 0, and the amplitude will be 1 if the t is larger than 0. Okay, so this is y-axis and this is the x-axis. So the amplitude always be 0 when t is less than 0, and the amplitude will always be 1 when the t is larger than 0. So this is ut and this is t. And then what is a ramp function? Ramp function is given as rt, or you can use different notation as well, but the amplitude will be 0 when t is less than 0, and the amplitude will be t when the t is larger and equal to 0. Okay, and then what is unit impulse? Unit means 1, so impulse is something like beats. Okay, so unit impulse is given as delta t, and the amplitude is always 0 when t is not equal to 0, and the amplitude is 1 when t equal to 1. okay, just as the graph shown here. Okay, next is rectangular signal. So given by the equation xt equal to a rectangular representing the shape of the signal, t divided by capital T. So the A is basically the amplitude of the rectangular, and the T is basically the duration, okay, the fundamental period of the signal. Okay, next is the triangular signal given by xt in this case. So triangular signal can be defined by this equation in which xt equal to a, the amplitude of the triangular, and then the modulus t, meaning that it will happen in both positive and negative t, and the t is the fundamental period of the triangular signal. So this is the fundamental period of triangular signal. Okay, meanwhile, exponential signal given by e to the power of alpha t. So the signal or the shape of the exponential signal will be dependent on the alpha, whether it is 0, positive or negative values. Okay, you can look at the figures here. So the alpha or the signal shape will be different depending on the alpha. If alpha equal to 0, alpha is less than 0, and alpha is larger than 0. Okay, you'll be using quite a lot of this signal as well, sinusoidal signal. So sinusoid represent the basic shape of sinusoid function. Okay, either it is sine wave or cosine wave. Okay, so you should be able to differentiate which one is cosine and which one is sine function. And next is the sin function. So sin function is not equal to sine function. Okay, so sin function is given by, so sin t, for example, equal to sin t divided by t. Okay, next we'll be looking at classification of signal. Okay, these are some of the signal classification that you'll be exposed to in this course. So you'll be exposed to continuous and discrete signal. So what's the difference with analog and digital signal, even and odd, deterministic and probabilistic, harmonic, energy and power signal. Okay, let's look at how the signal looks like for each of these classification. So the first one is continuous time signal. So this is when you have an amplitude at all instant time of t. Okay, so you can see different amplitude at different t. Next is discrete time signal. So in this case, you have only specific values at specific t. Or and in discrete time signal, we'll be using n representing the sequence, the bit sequence. If compared to continuous time, we'll be using time domain. An analog signal is basically more or less the same as continuous time signal. And in digital signal, you'll be having a range, more or less the same amplitude at a given range of time. Okay, next is the deterministic signal. So a signal in which the value is predictable. Okay, it can be reproduced identically, arbitrarily often. However, for probabilistic signal, it's also called random signal when the value of the signal cannot be predicted. For example, noise. Okay, next is the harmonic signal. Harmonic means a repetition of the same signal in sequence. Okay. Okay, so you can see at the bottom here some signals, whether it is harmonics or not. Okay, so the harmonic signal basically the fundamental signal ft that repeat itself a few times, okay, and represent the harmonics number, okay, the times the signal repeat itself. So the minimum value for t is known as fundamental period given by t naught. So from the figure here, you can see the t naught is basically a one cycle, okay, one cycle of signal that repeat itself multiple times. Okay, look at this figure, figure A. You can see repetition of the same signal by 3 times, first, second, and third. Okay, you have 3 harmonics. And in figure B also harmonic signal, because you can see the same shape repeat itself a few times, and the fundamental period given here is t naught for one cycle. So this is the first cycle, and this is the second cycle, and so on. Okay, how about C? Is this signal harmonic signal? Can be defined as harmonics. Can you see any repetition of this signal? So you can just see only one signal with fundamental period of t, but there's no repetition. So C is not harmonic signal. It's non-harmonics. How about D? You can see only one cycle as well. So it is not harmonic. Okay, so next what is even and odd signal? So its even signal is given by this equation, ft equal to f minus t, meaning that the amplitude of the signal is positive when t is positive, and the amplitude of the signal is still positive when the t is negative. It is also called symmetry signal at vertical axis. So this is the vertical axis. Okay, so you can see a mirror image. Okay, the amplitude is positive at positive t, and it is still positive at negative t. And odd signal defined by ft equal to negative f minus t. The amplitude of the signal is positive when t is positive, but the amplitude is negative when the t is negative. So for odd signal, it is also known as antisymmetry at horizontal axis. So this is horizontal axis. Okay, so it is antisymmetry. Okay, so when here is positive, here is negative. Okay, so when you look at the signal, when the t is positive, okay, the amplitude is positive. When t is negative, the amplitude is negative. Okay, so it fulfills the equation for odd signal. So look at the rest of the figures. So next, look at this figure. Why it is neither? Okay, when you look at the vertical axis, okay, you can see that the signal is basically a mirror image. So we can say this signal is even signal. How about the next one? This is positive and this is negative. Okay, so here you can see it's even, but here it is odd. So it cannot be grouped into even or odd. So that's why it is neither even or odd. And this one, when look at the vertical axis first, so you can see that's mirror image. on the same image appear on the left and the right hand side, so it is even. And please compare the rest two figures at the bottom. Next is skew signal. Skew, you can look at the shape here. It is skew signal and it's given by this equation. And hidden odd signal. Okay, odd signal combined with DC value, so it become hidden and odd signal. Okay, when you look at the original shape, it appears like the odd signal. Okay, so this is the y-axis. Oh, sorry, this is the x-axis. So when you look at the original shape, it's something like this. Okay, so when this signal is multiplied with a DC value, positive DC value, okay, so the signal become all positive. So you cannot see the negative part when the original signal being multiplied with the positive DC values. So the signal now being defined as hidden odd signal. Okay, in this slide you can differentiate between energy and power signal. So please read through the description of the signal and compare the two figures shown. Okay, to end the lecture session today, so I'll provide you with 4 different signals, A, B, C, and D. So please identify what types of signals for A, B, C, and D. So later I'll provide you with a link. So you need to answer to name what types of signal for A, B, C, and D in there. So I'll be recording your participation and attendance based on your answer. Thank you.